Have you ever wondered if you can create your own code interpreter like OpenAI, which can do multiple tasks like code verification, where it generates its own code, verify the code, and also provide the feedback like correctness and improvement? Or simply you write a natural language and ask the model to generate a chart like this, or you want to do complex task where you want to give your own data and ask the model to build random forest model for you, or you can ask the model to generate multiple models for you and give you the final answer which model performs better. Let's look at how you can solve this problem using ChatGPT agents in this video. So first we'll import all the necessary libraries and we'll import OpenAI's GPT-4 613 version. We'll solve this problem using OpenAI functions calling. OpenAI function calling helps us call a function based on a given schema. Here is a sample schema where you can give function name, a description of the function. You can include parameters like this function will have code, what's the description of the code, and how many are the required field. I have created a very simple schema function. This will help us generate this OpenAI functions calling schema for us using a very natural way of creating functions. So here is an example. In this example, we'll create a function called as Python. We want to have a code as a parameter, which is a string. It does not have any default value. And the description of this field is that you should provide the code in Python. This is the instruction for this particular function when to execute this function. This function is very simple. It gets the code, it executes the code, and it returns the result. And if there is an error in the code, it provides a trace back and returns a message that you should improve upon this error. So let's try and execute the schema and have a look how it looks like. So you see, we have from this function, we have generated the schema. So the function name is Python. You have Python here. You have the description of the function. Here is this entire description of the function. And there are parameters like code, it's a string. Please provide code in Python. All of these are taken from these parameters. So now we'll go ahead and say that we have functions as Python, and then we have a Python function available. It could be a multiple functions which you can execute. This code just checks whether the function has correct arguments or not. Now we'll write a multiple conversation function. What this function does is simply go ahead and call OpenAI functions. It checks whether OpenAI has recommended calling a function or not, or it should directly provide an answer. Once the OpenAI suggests calling a function, it will run that function and it will append the message in the messages array. It will iterate until the conversation is complete. So let's run this code. Let's try a very simple query. Find a Fibonacci number for 200. So let's run this function. As you can see, the model has recommended calling a function Python. It has generated a code argument with the code. And as you can see, here is the code. The function will ask yes or no before running this function. So we'll say yes here. And then as you can see, that model has run the code. It has returned the value of that function. And here is the number. Right? So let's now try a bit of a complex code where I want to create a chart which shows that 50% Microsoft, 20% Nvidia, and 30% Google. Now we are not specifying any chart as of now, but the model should understand and create a chart. Also, we want this chart to be displayed as a markdown. So we have written a very specific message that whenever you generate a code, you create a temporary storage called as temp image, and then you return the answer as a markdown so that we can display something like a chartboard. So as you can see, it has created a code to generate a chart. Now you can see that it has run the code to create a chart, and it has also written a markdown so that we can display this chart on a chartboard. As you can see, we have not specified which chart to create, but the model is smart enough to understand that it should be a pie chart. Now let's try and extend this function so that it can ingest a Excel or a CSV file too, right? So we have created a new function called as Excel CSV Python. It ingests the code. Also, it ingests a file name. It should be a Excel or a CSV file. We have given some messages to this function so that it can execute better. This is a similar code. The only difference is that now we are adding the file name as an argument within the execute function so that it can read the local file. Let's try and create a schema for this. It's similar schema as above, but now the file name can be optional. The code is a compulsory field. Let's add to the functions. Now here we have added a Titanic dataset, and we will write a query where we ask the model to create a basis statistics, and this is the path where the training file is. We'll run this function. Now here you see that model has made an error. It has not defined df. So in the next iteration, it will correct itself and it will try and improve upon the code. So now you can see that it has run the code and it will create basic statistics for us. And one of the benefit here is that it gives you a very natural language output rather than giving all of these statistics for you. So for example, here we know that it has 891 records. Uh, the approximate age of the passengers are 29.7 and so on. Now let's try and create a target distribution chart for a survival column and see what is the target distribution. So we'll run this message. As you can see, it tries to generate the code, but there's an error. So it will try and regenerate a proper code for us. Again, there is an error. As you can see, now it has created a chart for us. Now we know that survived column has 549 did not survive and 342 survived. And here is the chart. Now let's try and create a model. So we'll say that create a random forest model with 80-20% split, and the target column is survival. So we are appending this message on a conversation so it knows where the files are and what are the statistics for this file. Based on this, it will try and create a basic model for us. So let's see how it creates a model. As you can see, it has generated a code for us. Now let's try and run this code and see if it works. So again, it has made a mistake. It's important that you write a message in system message whenever a model is doing a lot of the same mistakes so that you can reduce the number of tokens. That is regenerated the code. Right. So now the code is executed successfully and we'll see the results. So here, since we said that we want to return all of these metrics, the code did not understood. He made multiple errors where the return was none. Now the function made sure that it returns some answer. So in the next iteration, it returned the classification report, confusion metrics, and accuracy. So now you can see that it has built a random forest model. The average accuracy is around 87%, and we have FN score, confusion metrics, and we have the explanation how to interpret these results. Now let's try and say that you already know some statistics, so create your own features and improve upon accuracy. Let's try and run this model and see whether it's able to create its own new features or not. Okay, so here you see that the model has created a new feature called family size, right? And as you can see, the model has now created a new feature called family size, and then it has rerun the model. Here in the code, it has created a family size by adding two features. There's no much difference in the accuracy improvement. So let's try another way where you can say that you create your own features, but at this time you create two models and compare both the models. So one model is random forest and one model is XGBoost model. Let's try and run this. As you can see, now the model has created two models. One is random forest and XGBoost. But let's try and run this model and see what answers we get. Now the model has responded with both the accuracies of random forest model as well as the XGBoost model, and it has concluded that random forest model slightly outperform the XGBoost model in terms of accuracy. So this is a very basic demo of how you can utilize code interpreter by building your own functions. Write in the comments below how you would utilize this functionality in your use cases. Thank you.